Welcome to Systems Thinking. Breaking down the true causes and possible solutions for the real-world problem of traffic.
Hi, my name is Jason Miller, and I'm a graduate student in the Chemical Engineering Department. We face a huge issue in Tampa, Florida, and that is the traffic. In 2023, it was estimated that in the year of 2022, the average driver lost about 51 hours of the year. As of 2025, the population in Tampa has increased by a little over 1% since 2019. This steady increase in population suggests that there will be more traffic on the already congested roads. This also means that as the population continues to grow, the average driver will spend more than the 51 hours they spent in 2022. While a system is an interconnection between a set of elements that interact to achieve some function or purpose, Tampa's problem with traffic houses both the issue and solution to its own operational efficiency. By identifying issues such as increasing population, limited public transportation options, accidents, weather, aging roadways and construction, work or school schedules, policy and funding issues, and a rush culture society in Tampa, solutions can be better approached and understood. All factors bear weight on the local economy, environment, and the public health of the city's residents. Solutions to overcome these obstacles are layered and must be viewed with a systems approach versus a reductionist approach. These include the cultural shift away from rush culture, enhanced transportation options, public education, policy reform, ride sharing, efficient use of technology, infrastructure improvements, enhanced safety measures, and remote work are all potential solutions identified. By taking a systems thinking approach, socioeconomic empowerment, cultural shift away from rush culture, and policy reform may be better leveraged by the City of Tampa for residents, policymakers, and structures such as the Department of Transportation. Systems thinking tools such as Iceburg model, causal loop diagram, and a comparative study of traffic between Zurich, Switzerland, and Tampa, Florida was conducted to highlight the interrelationship among variables within the system.
Hello, I'm Chelsea Mandrigas, and while I was the lead of this amazing team, it truly was a collaboration amongst 5 of us. As for a little bit about me, I am a dual master's candidate here at the University of South Florida, specializing in global sustainability and international affairs, concentrating in sustainable business and society and development, and receiving a certificate in climate mitigation and adaptation. As my colleague had mentioned, multiple tools were utilized to better understand the issue of traffic in Tampa. One such tool that I will be covering is the Iceburg model. And as we know, what is readily visible within a system may not always portray the full picture of how a system functions and what is driving its continuity. A systems thinking approach, therefore, will be employed to better analyze how traffic issues in Tampa can be addressed. Now, due to the complexity of analyzing traffic, the Iceburg is critical as it identifies the key factors or the variables involved in the system. As we start and we view what is visible at the very surface, and we begin to make our way down to the bottom of the iceberg, we can see that the model consists of events, patterns and trends of behavior, underlying system structure, and mental models. The event being explored, or what is currently happening, is that of traffic in Tampa via roadway issues and public transportation issues. The patterns and trends, secondary, consist of overall trends or happenings that feed into the event of traffic. Here we know this is seen in the form of transportation delays, accidents, local event timing, inclement weather, and environmental consequences of land use and exhaust. As we go a little deeper, we see the underlying structure is what influenced the event and begins to show the interrelationship between the variables. For our event, this includes the cost of transportation, limited policy, population growth, including the seasonal snowbirds, lack of infrastructure, growth and change over time, standardized work schedules, both the corporate and the school schedules, distractions via technology, traffic light issues and delays that lead to frustrations, lack of public transportation options, and how the policy follows funds, how roadway and transportation will typically disproportionately affect low-income persons, how technological advancements can move fast, and how policy can move slow, and this may not always replicate stakeholder needs. And finally, as we reach the part often unseen, but what guides what's visibly happening at the top, the mental models, These are the values, the attitudes, the assumptions that people hold about a system, and often what keep the system in place. In regards to Tampa traffic, the mental model is the overall rush culture. In the US, there's a need to be first in traffic. People will make last-minute lane changes. There's also this hyper-independency where independence is valued over community, or the presumption that you can go anywhere you want, whenever you want. The targeting factors deeper within this iceberg usually have more leverage within a system and influence the factors above it. Therefore, addressing mental models and the parts unseen within the system will typically create a more significant amount of influence and an enduring resolution for issues within the system. This will enable patterns and connections to become much more clear, which will help to make better informed recommendations for the future, leading to solutions that last instead of quick fixes that perpetuate the issue at hand. I'll be passing the baton over to my colleague who will be covering causal loops as our secondary tool.
Hi everybody, I'm Kelly and I'm a master's student in global sustainability. Next, we used a causal loop diagram to further investigate how these variables are interconnected with each other. A causal loop diagram is a powerful visualization tool that helps establish cause and effect relationships so that way interactions between factors in a system are more easily understood. It also helps us identify feedback loops, of which there are two kinds: balancing and reinforcing. Balancing loops have linked polarity in opposite directions, which means that they are counteracting. However, reinforcing loops are where the link polarity is in the same direction, which means that they are amplifying, and without intervention, these problems will only get worse. As you can see by looking at our causal loop diagram, we have identified the key variables and how they interact with each other. Starting with the amount of traffic, we can see as traffic increases, the length of travel time also increases. This leads to more driver frustration, which has two consequences. So the first is that it increases the pressure to improve roads, which leads to the policy to expand roads, which leads to road construction. And road construction has two consequences. The first is a short-term effect where it decreases the length of travel time. So the second effect is in the long term, so a delayed effect where it increases the amount of traffic. So moving back to the level of driver frustration, it also has a second influence where it increases the number of distractions. So the number of distractions increases, so does the number of accidents, which also increases the amount of traffic. Next, starting with the population, as population increases, public transportation options influence the number of cars on the road. More public transportation options means fewer cars on the road, and the number of cars on the road influences the amount of traffic. So the amount of traffic also has an influence on the amount of environmental pollution there is. So the pollution also increases the public health concerns, which has a delayed effect on the population. Finally, weather was also a factor that we took into consideration. So weather has two effects. First, it can increase the number of accidents if there's bad weather, but it can also decrease the number of cars on the road if people are choosing not to travel in the weather. Overall, our analysis identified 4 reinforcing loops and 1 balancing loop, which means that the system will not improve without intervention.
My name is Siobhan Herkert, and I'm a graduate student at the Patel College of Global Sustainability. I'll be presenting some of our solutions. Many solutions were discovered when taking a closer look at the relationship among the variables in the system of traffic. This is visible when taking a benchmarking approach at viewing best practices in other regions, in ride-sharing programs, technological advancements, structural and social infrastructure, remote work schedules, and even investing in public transportation. Ultimately, recommendations may coexist to build better overall system integrity. Places we looked for inspiration was Zurich, Switzerland. They were faced with some similar issues with overpopulation, congested roadways, increased drive times. They already had some systems in place, and they didn't want to start from scratch. but they used a multimodal approach which blanketed the city into a network of different transportation options. Now, they are considered having ultra-efficient public transport, and it is a great place to look for inspiration. While adopting shared mobility options, such as ride-sharing and carpooling, it would reduce some traffic in Tampa, but it would not get us all the way there. It just would not make enough of an impact. Tampa requires new, innovative, and integrated non-traditional ideas and systems like those in Zurich to reduce their transportation network's spatial and environmental footprint while maintaining the highest possible transportation efficiency. One innovation to reduce wait times is the application of data from Google. Using their AI models, they can reduce traffic wait times, reducing emissions and public health effects of traffic congestion. An emerging technology we haven't seen on the streets of Tampa, but are familiar with at Busch Gardens, is the air gondola. This transport system is often seen in theme parks, but we can apply it to our existing roadways and take the driver out of the equation and still get to where you're going, with a gorgeous view of the Tampa Bay area. Once proposed for the Tampa area, the project never really got off the ground. When a city invests in its own infrastructure for public transportation and safe roadways, investing in the innovative technological solutions for overcoming transportation and traffic trends, and it listens to its constituents, then the city directly empowers its residents and boosts the local economy. It's evident that rapid urbanization in Tampa has led to increased traffic and a higher dependency on vehicles, the opposite of the sustainable solution.
Hello, my name is Nectario, and I am currently enrolled in the University of South Florida's Global Sustainability Master's Program with a concentration in water sustainability. Now let's recap on what the team has discussed. They talked about how analyzing steady annual population increase with a systems approach can determine the interconnection between the issue, which is the overcongested amount of traffic in Tampa, by incorporating multiple approaches, including transportation, technology, safety, socioeconomic, cultural, and policy perspectives, which all contribute to the solution processes and interrelationships among the many variables within this system. The presentation incorporated how to deconstruct the complexities within a system and provide some potential solutions using a systems thinking approach to address the traffic in Tampa. Utilized was an Iceburg model, a casual loop diagram, and a global city comparison. The Iceburg model was developed as a framework to highlight essential system components such as patterns and trends, events, underlying structure, and mental models. The interconnection between these key factors determine critical aspects of the traffic problem involving policy and procedures. We learned that the rapid population growth, the inadequate transportation, and rush culture lead to accidents and safety issues. We talked about what factors it takes to uphold a functional traffic system, such as weather conditions, construction, and city events. Solutions to lower individual costs and provide affordable transportation can reshape the balance of Tampa traffic. The casual loop diagram illustrated a clear version of how the variables interconnect within the system, and a case study was presented to compare Zurich, Switzerland, and Tampa's similarities and new successful innovations, ideas, and solutions that Zurich strategically implanted within their traffic system to establish a sustainable traffic transportation cycle. Technologies were also introduced, such as GIS mapping that evaluates time and pollution waste in cities, a high-speed rail system that could boost Tampa's economy, an existing but creative idea of an air gondola that can be integrated as well. Ultimately, the system must positively impact the economy, stimulate economic development, and increase public transportation capacity while minimizing road traffic. The research has identified factors contributing to the problem and variables that contribute to the solutions. Without a systems thinking management plan approach, the transportation system in Tampa will remain unsustainable.